In this video, we'll be talking about the maxima and minima for a function and how to find these values and what they can tell us. So first, let's look at the graph of this function. Let's call it f of x here. So f of x, when we first glance at it, we can see that there is an absolute value, or I shouldn't say absolute value, but there's one value that is the greatest value that this function ever reaches, and it's at this point right here. We can also see that there's a smallest value that this function reaches, and it's right here. So we can call these the absolute greatest and smallest, or the absolute max and the absolute min value of the function. We can also call these the global max and the global min. But elsewhere in the function, we see that there's different peaks and valleys. So here and here, we have two peaks, and then down here and right here, we have, we can call those valleys. So more technically speaking, we would call these local max and local min. What we want to do in this video is figure out how do we calculate, or rather, how do we locate the global max and min values, and also the local max and the local min values. So we'll start by reading through a few definitions. The first definition says, we say that f of x has an absolute or global max at x equals c if f of x is less than or equal to f of c for every x in the domain we are looking at. And so you can read through each of these and just kind of see what these definitions are. Number 2 is a definition for a relative or local max, and that's when f of x is less than or equal to f of c for every x in some open interval. So that's a difference between the definition for number 1 and number 2. So in number 1, we have an absolute or global max. That's just the highest value for the entire function. And that is having to do with a specific domain that we're working on, or a specific domain that we're concerned about. And this differs from a relative or local max when we talk about just some open interval around C. And we'll talk more about what that looks like. And then definition 3 and 4 is talking about the difference between an absolute minimum value and a relative minimum value. And again, the absolute value is for every x value in the domain, whereas the relative or local min is for just the x values that are in an interval around some value c. So let's clarify a couple of these phrases in these definitions. The first thing to clarify is this phrase, open interval around C. So what we're saying is C is some value within an interval along the x-axis. And C is just inside some interval. So C is inside an interval, which also means that C cannot be an endpoint of the interval. Right? If C is an endpoint, it cannot be an endpoint of the interval. I mean, that makes sense. If C is inside of an interval, it can't be the endpoint of that interval. So that's what we mean by an open interval around C. Next, we want to talk about the word extrema or extrema. I've heard it pronounced both ways. But this just refers to both the max and the min, either the relative max and relative min, or the global max and global min together. So what we say is that the relative extrema, that is the relative max and the relative min. Max relative max and min together, and then the absolute extrema, that's just referring to the absolute max and min together. All right, I also want to bring some clarity to the difference between the phrase or the term absolute versus relative. We can refer to absolute sometimes as the global max or min. So absolute max or min, same thing as global max or min. And then relative max or min, we could refer to that also as the local max or min. So when we talk about the absolute or the global extrema, this just is the value f of c, so the output value of the function, that is the largest or the smallest value in the domain. So when we use the term absolute, that just means the absolute greatest or the absolute smallest values in the domain. This is different than the relative or the local extrema, where f of c is just the largest or smallest value in some interval around c. So if we look at some graph of a function, let's say that's our function, f of x, and let's say this is c1 and c2. Let me go in order here, left to right. Okay, so we have c1, c2, and c3. So this value right here, we would say f of c1. So that value is going to be a relative minimum value because the values around c1 are all greater than f of c1. So the values to the left here are going to be greater. The values to the right here are also going to be greater. So the value of the function at c1 is the smallest value in that interval that's right around c1. And so similarly, we can say the same thing for c2 and c3. And so this was mentioned previously, but a relative or local extrema or extreme value cannot be an endpoint of the interval. An endpoint of the interval. Because if it's the endpoint, that we don't know if beyond that endpoint of the interval, the given value, the c value in this case, is actually smaller than everything else in the interval. So let's look at an example. It says, find the relative and absolute extrema for the function f of x is equal to x squared on the interval -1 to 2. So remember, when we say relative and absolute extrema, for relative extrema, that means just find the relative max and min. And then for absolute, that also just means find the relative max and min for the function f of x equals x squared over the interval -1 to 2. And this is a closed interval, so we're going to include -1 and +2 in that interval. So the best thing to do probably is to look at the graph. All right, so this is what our graph of x squared is going to look like over this interval from -1 to 2. So let's talk about, it doesn't matter, how about absolute max and absolute min first. Okay, so again, the absolute max is the greatest value that this function ever takes on in this interval. So the absolute max is going to be right here, so that's going to be 4, and that occurs when x is equal to +2. The absolute min value is down here, that's going to be 0, and that's when x is equal to 0. So those are hopefully pretty straightforward. Now let's think about the relative max and the relative min. Well, the relative minimum values, again, are the values that give us a low point on the graph. So the relative min is going to be located right here. So this is also going to be 0 at x is equal to 0. Oops, I have that backwards. I wrote it in the wrong spot here. So the relative min, we're going to say 0 when x is equal to 0. Now, the relative max, well, it seems like this value right here might be a relative max, or maybe up here. But what we saw is that a relative max cannot be the endpoint of the interval. So we're not going to say that there is a relative max here. So for this particular function, there is no relative max. So a couple things to point out, or maybe just one thing really to point out here, is that the absolute min of this function and the relative min are the exact same thing. So one thing to just keep in mind is that this is possible. The relative min and the absolute min could be the same value. Likewise, the absolute max and the absolute min could be, the absolute max and the relative max could also be the same value. That's not the case for this particular function, but it is possible. All right, let's look at a second example, and this one is quite like the last one. The only difference here is that the interval we're working on is different. So again, let's find the relative max and the relative min, and the absolute max and the absolute min. So for our absolute max value, again, it's going to be 4. But in this case, it occurs at 2 different locations. So we're going to say 4, and that's going to be when x is -2 and +2. We have the same absolute minimum value. That's going to be 0, and that's when x is equal to 0. For the relative max, we're still not going to have a relative max here. Again, we would think it's maybe here and here, but again, the relative max cannot be on the endpoint. So the relative max, we're going to say none. And then for the relative min, we're still going to say that this is 0 at x is equal to 0. So what we should point out in this particular example is the absolute max value, that could occur in multiple places. And again, the absolute min and the relative min are the same here. So just by changing the interval, that could very well change what we get for the absolute and the relative extrema. All right, so same question, find the absolute, relative and absolute extrema for f of x, and f of x is x cubed, and we want to look at that over the interval -2 to +2. Okay, so I always like to find the absolute max and the absolute min first. So the absolute max, this one is up here. This is going to be 8, and that's going to occur at when x is equal to 2. And then the absolute min is going to be down here. That's going to be -8, and that's when x is equal to -2. For the relative max and the relative min, well, there's nowhere in this function between -2 and 2 that we could come up with an interval that we'll have a value that is smaller than anywhere else in the interval. Similarly, we can not draw an interval on this function where a single value within that interval would be greater than any other value inside that interval. And again, we can't use these endpoints. Okay, so we might be thinking, well, what if I just look around -1 to +1? Well, to hammer this point home, there's no value within this interval that is going to be smaller than every other value in the interval, right? Similarly, there's no value within this interval that is greater than every other point in the interval. So that means there is no relative max or relative min for this function. Now, let's suppose that the interval here was from -∞, well, it's not going to be a closed interval, -∞ to +∞. So if this was the case, if this function, let's say, just kept going to -∞ and +∞, we would still not have any relative extrema. And in addition to that, we would have no absolute extrema. So what we would say here is, if the domain is -∞ to +∞, we would say there are no extrema. There are no absolute max or mins and no relative max or mins. So let's look at one last example in this video, and it says to find the relative and absolute extrema for f of x equals cosine of x. So I'm just going to graph this by hand here, kind of zoomed in. So this is +1, this is -1. The period for cosine is 2 pi, so I'm going to mark off a couple period lengths here. And let's keep going. Let's say -6 pi, and then +6 pi over here. So if you can recall from our trig days, the cosine function bounces between +1 and -1, and it starts up here at +1, and then it crosses at the quarter values of the period. So this function is going to come down here and comes like this, and it's going to continue in this pattern all the way, well, forever. So it's going to go down like this, and then like this. And that's going to do the same thing in the negative x values. Okay, so let's say that this is what our graph is going to look like. So we want to find the relative and absolute extrema for this function. So let's first look at the absolute max and the absolute min here. Okay, well, it looks like this function has a maximum value of 1, and it occurs, at all of these locations. So there's an infinite number of absolute maximum values, and those occur every factor of 2 pi, or I should say every time 2 pi is multiplied by some integer. So we would say the absolute max is 1, and that's when x is equal to, we could write it like this, -4 pi. Hang on, let's write it like this. So dot, 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 -4 pi, comma, -2 pi, comma, 0, comma, 2 pi, comma, 4 pi, and so on. We could write it like that. We could write it more precisely, or I don't know. We could come up with a formula for all of those. We could write it like this. So the maximum value is going to be 1 at x equal to 2k pi for any k integer. So anytime k is an integer, that gives us the locations for all of those maximum values. The absolute minimum value is very similar. That is occurring, it's going to be -1, and that's going to occur kind of at the halfway point of all of those periods. So we'd say -1 at x is equal to, and same idea here, but we're going to say -3 pi, -pi, pi, 3 pi, and so on. So similar idea, and we could write a formula for this by saying the absolute minimum is -1, and that occurs when x is equal to, what would we say? We want to start at pi and then add 2k pi for any k integer. So if k is -1, that gives us -pi. K is +2, that gives us 5 pi. So yeah, that would work. All right, so that's how we can come up with the absolute max and absolute mins here. And let's think about the relative max and relative min. Well, in fact, these are all going to be the exact same. So absolute max and the relative max are both satisfied by all of this. And then the absolute min and the relative min are satisfied by all of this. So let's dissect that just a little bit. So the relative max, remember, if we can draw some interval around, let's say our interval is here to here, so around 4 pi. Well, there is a point, and it's right here, where every other value in that interval is less than +1. So we would say there's a relative maximum value of 1 at 4 pi. Similarly, let's say my interval, it doesn't have to be on the x-axis. I could have my interval start here to here. There is some point, namely, what is that? 3 pi. So at 3 pi, the value of the function is -1, and everywhere else in that interval is greater than -1. So that tells us that this location down here is a relative min. All right, so that's it for this video. In the next video, we'll talk about 2 key theorems and then how we can find some absolute extreme values.